los acelerómetros, y esta vez estamos cambiando la variable, estamos presentando lo que son distintas opciones de sensores acústicos y micrófonos que trabajamos junto a PCB. Bueno, somos Varitec, una empresa dedicada a tecnologías predictivas, todo lo que son sistemas de adquisiciones para monitoreo de máquinas rotativas, principalmente dedicado a la parte industrial, pero bueno, personalmente yo estoy en la parte siempre más enfocada en la parte académica, en consultoría, en universidades, para proveer soluciones completas de adquisición de datos asociadas a migración y micrófonos. Somos una empresa que nació en el año 98, dedicada a la mantención predictiva. Empezamos trabajando en el 2008 con PCB Piezotronics, distribuyendo directamente y ofreciendo apoyo en selección, apoyo en postventa. Trabajamos directamente integrando sensores PCB Piezotronics en nuestros sistemas de monitoreo predictivo y en nuestras soluciones de adquisición de datos. Actualmente también trabajamos con Divisoft, Sensotec y RD Balancing como empresas que van agregando valor a la parte de monitoreo de condiciones y medición de vibraciones. Somos una empresa que tiene alrededor de 500 proyectos en la parte industrial, en monitoreo de vibración en plantas, principalmente en la parte minera, pero también en la parte industrial papelera, y en la parte más bien dedicada a fabricación de acero. En integraciones en terreno obviamente tenemos gran experiencia enfocados siempre en una cultura cero daño. Y bueno, contamos con oficinas actualmente en Santiago y en Calama para dar servicios a ingeniería, integración, capacitaciones. Y en realidad tratamos de apoyar a todo el país en lo que es la parte de instrumentación. Dentro de las líneas que trabajamos, trabajamos a la par con PCB en sus divisiones industriales a través de IMI Sensors, dedicadas a sensores para uso industrial, monitoreo permanente, monitoreo en ruta de vibración, y la parte de test o investigación y desarrollo de PCB Piezotronics y en DevCo. Complementamos estas soluciones con sistemas de adquisición de datos en la parte industrial con Rockwell, pero para aplicaciones de I+D, de test, usamos y ofrecemos soluciones completamente compatibles entre ellas, integrando Divisoft y PCB. Para soluciones de calibración acústica de vibración, Modal Shop, una división de PCB Piezotronics dedicada completamente a la fabricación de sistemas de calibración portátiles o de laboratorio, y también, bueno, ahí fabrican algunos equipos digitales para adquisición de datos y para, en realidad, complementar las capacidades de PCB Piezotronics. En general, tratamos de ofrecer servicio, o sea, el sensor y los sistemas de adquisición de datos lo más complementariamente posible, y en realidad apoyar durante toda la selección, capacitaciones, y lograr que ustedes y los usuarios finales en general puedan tener una experiencia sin problemas, y que los sistemas o sea, que obtener el dato no sea una barrera, simplemente que tengan los datos más precisos posibles a través de las soluciones de PCB y Linux. Dicho esto, bueno, le doy la parte técnica, está dictada por Carmine Salzano, eh, que ha trabajado por varias décadas ya en PCB Piezotronics en la división de Test and Measurement, y bueno, a través de él podemos organizar estos webinars que se enfocan más bien en apoyar la parte de Test and Measurement, de investigación y desarrollo de PCB Piezotronics. Me acompaña Benjamín aquí, nuestro líder de marketing, que también, bueno, él me ayudó a organizar todo esto y a hacer que esto sea un poco más, poder llegar a ustedes de manera más directa y constante. Y bueno, nuevamente agradecerles a ustedes, a Carmine y a Benjamín por esta instancia. Y bueno, dicho esto, le doy mi paso a Carmine. Bueno, este webinar va a estar dictado en inglés, pero Carmine puede entender perfectamente español. Cualquier pregunta que tengan, pueden levantarla al final en inglés o en español. Carmine.
Muchas gracias, Nicolás. Muchas
Gracias.
gracias. Buenos días a todos. I will not speak in Spanish. I apologize. No hablo español. So this presentation will be in English, as you can imagine. I will share my screen now. Hope you can see my screen, right? Can you see? Is okay? Nicholas? Hello? Nicholas, please speak.
Yeah, we cannot see right now.
Okay, can I go ahead?
Yeah, no, please share again. Yeah. So,
should I share again?
Yeah, please. I can see it here.
Okay, let me share again. Can you see now? Guess you can see, right?
Yeah, there you go. Perfect.
Okay, perfect. So I will make this presentation. Just a little word from me. I'm responsible for all international support at PCB outside the US. I'm part of US organization, but I'm calling now from Italy because it's very well located between the two words, East and West. The agenda today will be, as you can see from the screen, and at the end of the presentation, take notes of your questions, and I will answer your question basically. Nicholas, anytime you have any problem with audio video, please call me, okay?
Sure.
Or even if you have to speak slow, okay? Okay, so the agenda. It's not easy to build an agenda on microphones because you want to also add the acoustic review, basic acoustic review. But of course, in less than 1 hour would be not possible. So that's why I made a choice to just mention a few working principles of the microphone, the measurement microphones, and then go ahead with the little things about usage and calibration. And then the most bigger part will be some technical data of our microphones, and we will go to the application and selection of the real application, where we can see some example how to choose and select the proper sensor, the proper microphone. Okay, that's the agenda of today. Of course, PCB, I guess everybody knows, is a world leader company. It is born more than 50 years ago in a basement. Now is a big company with the 7 factories in US and location around the world. The working principle microphone is we call a condenser microphone. It's a main transducer to measure the sound, so in the human ear range. As you can see, we have other transducers like the microphone headset I'm using now, or the computer microphone and so on. But we cannot call as a measurement microphone. The measurement microphone is one that is a linear response all over the frequency range, possibly wider than the frequency range of the sound. So below 20 hertz, above 20 hertz. This, and of course, the behavior is perfectly linear, and not like a music microphone or the studio microphone, which are dedicated to words, to the sound of the voice. That's why it is more likely exaggerating around the 1 kilohertz. However, this microphone measurement should be flat response, very precise all over the frequency range. How it works? We call condenser because we form a condenser. So we have a backplate rigid here. I hope you can see my cursor.
Yeah, we can see.
Should I use them? Okay, so you can see the backplate rigid, and then we have a diaphragm, very tiny. We talk about micrometer thickness, and the distance is also micrometer. So very, very tight tolerance. The rest is a grid. Now we form a dielectric with these two plates, where one is fixed, the other one is moving, the diaphragm. Moving subjected to the air pressure, to the movement, right? Or the air pressure, which are the sound, which is sound is just a train of air, compressed and not compressed. So the principle, you can see the output, the electrical output is based on the electrical voltage of the backplate, where we give 200 volts from externally polarized, or we use a electrolyte layer on the material. This way we call pre-polarized microphone. So once we have this, D0 is the distance at rest position without any sound. E0 is the charge, of course, as I already mentioned, two ways, pre-polarized or externally polarized. Then the only thing changes is this the actual distance, which goes back and forth, this diaphragm subjected to the sound pressure. You can see here, sound pressure will deflect the diaphragm. This tiny distance change the output. That's basically the principle work in a very, very easy matter way to show. With a single microphone, of course, we measure a number. We measure not a vector, but a scalar. So we measure the sound level in one point. With the two microphones, however, we can measure also direction, which means we can measure the vector. And with the multiple microphone, we can have a more complete view of the acoustic situation in that particular area. Every single microphone is not an invention of PCB. It should be subjected to very tight tolerance. Everything is under standard, IC standard, including the precision class. Type 0 is typically used for lab style, like calibration reference. Type 1 is the one used, typically the 378 series of PCB used for precision measurement, like, I don't know, acoustic certification. Type 2 is for array microphone, typically. Of course, the precision is decreasing, of course. So now, typically, we have three microphones. I remember more than 20 years ago when I started to work at PCB and before in another company, we do have still a 1/8-inch microphone size, which you still can find on the market. But today, with the new 1/4-inch microphone, we can achieve also this kind of performance. And you can see the bigger is the size, as usual, the bigger is the sensitivity of the sensor. So you can measure very low level. But on the contrary, the frequency range is in the high frequencies reduced. So this is an exercise you can guess that you can, if you want to measure, however, higher range of dB or level, you can use a lower range microphone. This also explains why the half-inch microphone is the most common microphone used in sound measurements. The other one is 1 inch is typically in some audio measurements, like mastoid or this kind of audio measurements, calibration. 1/4 inches for very high level, like in the close to jet engines and this kind of stuff. I already mentioned before the polarization, the way to supply the voltage to the microphone in order to form the condenser, right? Now, originally the microphone were only externally polarized with the 200 volt. Then, with advent of ICP or IP power, we can use the Eltet rate on the backplane, and we charge constantly and continuously forever the backplate. So in this way, you don't need any extra 200 volt, and you can use this microphone also with the portable instruments. So today, most of the we still manufacture pre-polarized, externally polarized microphone, but most of the microphone today are pre-polarized because they use the benefit of ICP supply. One or the other important, I should say a lot of things regarding the basic of microphone, but I just pick up a few of them, like the polar pattern, which state the omnidirectionality of the microphone. Of course, the microphone in front is capable to measure very well, but it's very important that is able to measure on the back of the microphone itself. And this is depending on the field of measurement, which means the microphone also has a typical behavior in the fields we will see in a moment, but also the sides of the microphone affect itself the sound environment. The sound field, in fact, is disturbed by any solid object. In this case, if you have a large microphone, you will be sure that it will affect a lower frequency where the wavelength is large enough to be compatible with the sides of the microphone. On the contrary, small microphone will affect the high frequency range where the wavelength is small, comparable to the sides of the microphone. So we need to pay attention in this case when we measure in the field, choosing kind of sides of microphone. But I already mentioned, the microphone also, we define it based on the three typical environment, three typical fields. One is a free field, like we measure outside in the field or in an anechoic room, where we have a perfect no reflection at all. So which means that every 6 meter or 3 meters, depending on, we will see later, we have a decrease half of the sound level. However, diffuse in diffuse field, which you can find in a perfect reverberant room where it's a full of reflection, in this case we can use another type of microphone, not free field but random field, because it's able to measure in any surface. In this case, ideally, in any point of this reverberant room, the level of measurement would be the same, ideally. The third surface is a pressure, which is like in a pipeline, like when using a pressure sensor. The same size, the same way to use of the microphone, unless, of course, we need to pay attention that microphone is purely only to measure air or a gas, not sure a liquid. But all three of the microphones measure the same things until 1 kilohertz. So why? Because 1 kilohertz, more or less, most of the microphone half-inch, they have the same certain sites which not affect the lower frequency, because you will have such high or large wavelengths which is not affected by the sides of the half-inch microphone. Therefore, the three microphone fields type will be differentiate themselves from 1 kilohertz and above in frequencies, as you can see from here. So this is another good tip to remember when you select a microphone for measurement, precise measurement. Of course, every microphone is delivered by PCB with a regular precision calibration certificate, where you can see the type, but also sensitivity, open circuit. You can see the type of microphone, if it's a free field, the size, and all the frequency response sensitivity at each frequency type range. Finally, the transducer is also available today in most of the pre-polarized microphone ICP, because it's another chip additionally, which is placed inside the microphone to measure and to know exactly the type of microphone, including calibration certificate, all in a chip. Of course, you need to have the proper data acquisition with the TETS capability reading. Okay, that's, as I promised you, a very, very short introduction on the microphone. Now, the most important is how we can use properly the microphone, because microphone, you can already best, is a very delicate instrument thanks to the diaphragm, which is very tiny, can be easily broken if you dismount the grid. So, which type of tips we can give? First of all, always store the microphone in a dry place, not leave in a test cell, for instance, or engine, because you have fumes, you have dust, and so on, and humidity. Also, every time you have to tie the microphone on the preamplifier, always hand tight, never use any grip. Also, if you need to clean the microphone from the dust, first of all, do not dismount the grid, but use a very gentle blow, and not use air shop, of course. Do not touch diaphragm. I already told you, never dismounted the grid and never touch the diaphragm. If you touch the microphone with your finger, 100% sure is broken forever, cannot be replaced, the microphone, the diaphragm. Of course, as I said, leave the grid cap always. And of course, be careful, even if today we have a good news, I will explain later, never let drop the microphone, because of course you can damage the diaphragm. Every microphone, I already said, is calibrated, because it's accompanied by a calibration certificate. But how we can perform this calibration? First of all, we generate this calibration certificate in-house at PCB after the manufacturing. But of course, this is a level of laboratory standard. But every time you need to perform a calibration, you need to have a reference microphone and then compare with the actual measurement microphone under calibration. So we have a new calibrator, the old one, and this is new one also with the screen. And this new one is the basic. Okay, we cannot call calibrator. It's just a verification. You can verify that at 1 kilohertz, for instance, you exactly measure, I don't know, 94 dB, for instance. If you don't measure this, but you measure, I don't know, 80, then of course something is wrong with the microphone. Maybe it's broken. So this is important. Even if you have one single unit of microphone, one microphone, please always use this calibrator before and after every measurement, always, because otherwise you will never be sure that the measurement is done perfectly. Of course, if you want to, however, to verify all frequency range, then in this case you need eventually a portable calibrator where you can adjust the level and you can adjust also the frequency. So you can verify in this little box here, also portable, the full calibration system to verify all the sensitivity and the complete range of frequency. That's very convenient choice for users that have a multiple microphone because it's very cost effective. Otherwise, for calibration department, for calibration lab, also using this service outside, we have a full calibration system, as already mentioned by Nicholas. We use this one, for instance, made by Model Shop, our division. So let's see now quickly some products and technologies. First of all, I would like to stress that PCB put a lot of stress on manufacturing standards. We have a vertical integration manufacturing with all type of military standard, quality standard, and vertical integration for the production, which means we are able to change anything on our sensor. But then we need to justify, put a lot of tons of paper, okay, for his ISO standard. Therefore, it's a very long process. So it's not the PCB capability, it's just a matter of this standard. Also, we hold a lot of facility in our production, 7 factories in US, you can imagine, only for sensor manufacturing. For instance, every single microphone is put in an environmental chamber, like here in my cursor shown. So before calibration shipment, we put in an environmental chamber to test temperature, humidity before shipment. And also we calibrate in an anechoic chamber, we laser weld, and also we assemble our microphone from the scratch, from the beginning, in a clean room. We also have a separate clean room for force sensor and for pressure sensor. So just to show the quality stress we put in our production. The quality, you can see here some technology. We have some particular technology like the low noise microphone, the water and dust microphone. This is a phantom microphone, which is really nice. And then we have the flat microphone. Let's see each one. First of all, let's start with probably the last microphone developed this year. Is a 37808. Is a free field, but for the first time, a free field quarter-inch microphone has reached the sensitivity of 50 millivolt per Pascal. What does it mean? Which means that you can use the same sensitivity of half-inch microphone. But being a half quarter-inch, you can measure higher frequencies. Therefore, this microphone not only can work in the free field, but also in the pressure field and in diffuse field. Okay, so it's a very interesting news about this microphone, thanks to this capability having quarter-inch and very high sensitivity. I already mentioned before, never let drop on the floor the microphone. Right, this is true, because you will break, and even if you have a grid, you will break the diaphragm outside. However, we develop a new grid. Instead to develop a rugged microphone, which maybe costs too much, we develop simply a grid which makes the microphone more resistant. So you can replace the standard grid with the new grid, and this grid is qualified to resist to have less than 1 dB deviation when you drop 1 meter on the floor of the microphone, or hit the wall, for instance. This is a typical problem happen during measurements. Also, you have a different accessory like this one, which is really nice, is a holder, which is allows you to mount the microphone anywhere. Now, this is IP55 certified microphone. What does it mean? It means that it's resistant to water and dust and oil spray. Of course, you cannot submerge to the water, okay? But if used in the rain or close to breaks where you have oil, or in a particular environment where you have a lot of dust, there's no problem because it's IP55 certified. How we can reach this? We can reach because we have two pads. One is internal, not removable, to protect the diaphragm. The other one external, right below the grid. And this one is removable, which means when it's full of water, dust, and oil, you can simply peel off and use another one. Very easy. It's very cost effective, this solution. Then we have the 3mm thick, including preamplifier flat microphone. This is very interesting when you want to measure the surface sound, the sound in particular surface. So you can easily glue without drill the surface like in a car. You can see a standard part of the car. You can mount the microphone and measure the in any position the sound in that surface. That's another interesting microphone, which is the probe microphone, where inside you have a typical microphone pre-polarized. Then we have different tips. At the tip of this probe here, you can measure in any particular hidden space, but also inside the engine, for instance, because it resists up to 800 degrees Celsius. So you can measure up to 160 dB to 20 kilohertz, but you can resist up to 800 degrees Celsius. So you can imagine how many sound measurement can be done with this microphone. This is really unique. This is today the only ATEX approved microphone. I know that in Chile, when I visited a couple of years ago, 1 year ago actually, you have a lot of mining, right? Well, there are some explosive areas where you cannot make measurements, right, with the sound or using a precision measurement microphone. However, today, this is the first intrinsically safe microphone to disseminate with AX approved. So you can use it, for instance, for leakage detection on the pipeline, inside the ground, outside the ground, in any explosive area. That's really interesting because, I repeat once again, it's unique in the market. Then we have already mentioned the phantom preamplifier. This is especially for the audio world, okay? Everything is okay, Nicholas, you can hear me? Okay. Should I speak slow? Is okay.
I think it's good speed.
Okay. Now, why the phantom amplifier? Because you know that we have this microphone with the preamplifier, half-inch or quarter-inch. The problem is this is ICP output and cannot be connected to the audio system like speaker manufacturers, studio microphones, and so on. So now we made this phantom amplifier, which connect this preamplifier to the 3-pin output, typical in the audio system or recorder, with a 3-pin output at 48 or maybe 24, 12-volt capability. So it's very nice because for the first time, we can use the very highest precision microphones, even in a studio recording, okay? So, or even loudspeaker manufacturer and so on. So it's open all the audio world by this connection to the phantom amplifier. The first low noise microphone developed in the market was a PCB one. Yes, because I remember 30 years ago when I started to work in another company, the microphone was externally polarized. For the first time, some years ago, PCB developed a pre-polarized. Why? Because, of course, measuring at with the threshold of 5.5 dB, you need to have to solve all the electronic noise inside the preamplifier. That was the problem. That's why externally polarized was used. But now we have a pre-polarized, as you can imagine, very conveniently use it. And the threshold is 5.5 dB with a half-inch microphone, typical free field. And you can imagine when you want to measure a 15 dB, where is the threshold of typical half-inch microphone, that is noise you will going to measure. So it's true that if you want to measure the noise from PC, for instance, you need to put in a silent room. In this case, you can use this microphone. Okay, now we move to the last part. Last part is a collection, some example, because it's impossible to cover all the sample. For instance, I cancel from this presentation all automotive and aerospace example, because otherwise was too big. the the part. And of course, we have a limited time. And most important, I would like to hear your questions. As you can see, I just summarized some application, of course. But now, first of all, let me say that when we measure the sound, we measure a pressure, an acoustic pressure field, dynamic pressure. So you can see, so we are in the roll ends part of the pressure. So we talk about few tenths of psi or 10 dB to 77 dB. So, or under 20 dB. So you are in this area with the microphones. In the same area, but a little bit more above, we have another technology, which is not condenser, but is more robust, is a piezoelectric pressure sensor, which is able to measure from 77 dB. So in some high-end area of the microphones, but it's also much higher in frequency also. And above, we have a pressure sensor also using for blast test and above ballistic. So here is just a plot of frequency and the level of pressure. Whatever you want to call acoustic or non-acoustic is a dynamic pressure anyway. The half-inch microphone is or the condenser microphone is the most widely in terms of dynamic range, which is the contemporary measuring from 10 dB up to under 70 and 80 dB. The array microphone have a limited space, also pressure, piezoelectric, high sensitivity sensor, they measure a little bit above, as already said. So this gives an idea that we can cover any type of measurement with our sensor, microphone or pressure sensor. And for microphone, is very helpful this selection chart, which you can find on the acoustic brochure. I guess Varitec can send to you, or you can easily download from pcb.com. You can see,
lo vamos a enviar junto a la presentación. No, sorry.
So,
the presentation.
no problem. Okay. So here we have three different colors because we have the microphone are different, free field, random, or pressure field. Then the level of range is here, 15 to under 45, 35 to under 64, and so on. That's the dynamic range. And then we have here the frequency range. You can see the minimum and the higher frequency range, and the size, of course, if it's half inch or 1 inch. So all the most important specification in order to select the proper sensor, including sensitivity, are in one plot here. So you don't need basically anything else. So if you need to make a measurement, you need to select a sensor, use this simple chart and immediately will select the sensor, use it for your application. But of course you need to know which are your requirements. So I can give you some example. For audio measurement, of course, I would recommend, for instance, the phantom amplifier. For measuring very low level, like measuring the noise from a computer, right? Then, of course, it's a low noise microphone. Very high level, you want to measure above under 70 dB, you can use a 378-812. Or we have a microphone which is able to measure from 0.13 hertz, almost 0 hertz. So almost static pressure, but not, because intrinsically it's a dynamic sensor. So this is another way to measure, and they will see the application later. Oil and dust environment, of course, the water and dust microphone under 30 B24. Surface measurement, the surface microphone. Duct, you want to measure in a duct or in a hidden space, you can use a probe microphone. If it's an array application like holography, with the multiple microphone, you can use array microphone. And remember the accessories, which are very important. So the first example of this conclusion part is, for instance, appliance. Appliance, you need to make different type of test. First of all, you can make an holography. In this case, use a series of array of microphone. Or you want to measure a noise certification. In this case, you can use one microphone or some microphone, for instance, to measure the power, some power for CE mark, for instance. This case, 378B02. And if, however, you want to investigate where noise came from, you want to put the tip inside the appliance, then you can use the sound probe. Very similar is also audio speaker. But the only difference, because since we're moving in the audio words, very effective will be to use a phantom amplifier, because in this case you can we can make very high precision using our microphone and using the data acquisition from audio directly with a typical 3-pin input. The microphone already measure the low noise. It's very useful to measure very low noise sources, like my computer fan or any other low noise emitter. Of course, what you need an anechoic chamber or a silent room at least, right? Because the level, in this case, you want to measure below 15 dB. Here you can see some other measurement sensor like accelerometer, force sensor, but basically in air conditioning you need to want to measure the noise, because this is the most disturbant, and you can use a typical 378 BO2 free field half-inch or the low noise microphone. For noise reduction, however, the same things. You can use the microphone free field, or you can use the probe tip to go investigate inside the end tools. Also, another application very nice is to measure on the musical instruments, because you want to record and measure very precisely the sound produced and analyze this sound. So you need a very high level type 1 microphone like 378 BO2, for instance, maybe free field. But you also, in some other application like a building acoustic, typically you can have a random field, but sometimes you can have also free field. In this case, having a diffuse field, you can use a random type microphone like these two types. However, if you want to qualify the material in use, the regular size of material, then you need a particular setup. You have two environments. One is an anechoic room, the other one is reverberant. In this reverberant room, you use a microphone, of course, random, because it's a reverberant room. In anechoic, of course, use a free field microphone. Now, switching on two loudspeaker, you measure the sound here and the sound here, and you will see the difference, right? And this way, having the difference, you can measure the transmission loss or the absorption of this material under test. But this can be done in a very small, convenient way in a Kuhn tube. Kuhn tube is a sample of this material, not real size, but just a sample. And in this case, you can use a 1/4-inch high range microphone in terms of level, because you have a sound source here, and then you can measure inside the tube the transmission loss or the sound absorption or this sample of new material under test. This level of component can be done because every single component, pumps, motors, anything, need to be tested before a final assembly. And in this case, you need to define the sound power emitted. In this case, you can use a relative microphone, precision one, maybe following the ISO standard to measure the sound power. I can share with you another nice experience, which is a component level. You can see this like a Christmas tree here with the rods in metal. These rods are circular, cylindrical, and with the diameter very small, let's say less than half centimeter, very, very small. So which was the problem now? You want to do a model test on this particular steel tree, right? Now, if you want to mount an accelerometer, you cannot mount because it's a circular and very, very small diameter, right? If you want to use a laser scanner, also, the diffraction will be not possible because it's a very small cylindrical. So what you can, I can suggest, something we use it already. Use a microphone in an anechoic room, for 378 PO2 or the low noise one. And in this case, you can measure the movement of this and measure the noise and especially the resonances. So the model parameter of this particular device. It's an application which can be open the mind, which I would say there's the vibroacoustic phenomena are very closely related. And of course, you can see that for any low level measurement, I try to list some of them, or using the low noise microphone, you can have a lot of benefit. Contrary, very harsh environment. you can see the petrochemical plant or in oil and gas or in close to breaks. You want to measure in such harsh environment where you have a lot of water spray, oil spray, dust. In this case, 13824 is a perfect choice. We made this sensor especially for brake test of the car, just to give an idea, close to brakes. That's a particular one. This is a low frequency. I already mentioned 0.13 hertz, if I remember well, is the minimum frequency. So it's below the human ear frequency range. But you can imagine how many applications you can have. First of all, tornado. We have some tornado seeker people that do this in US, or earthquake detection, or sonic boom, or any other environment, like also wind turbine measurements. Every single event, no acoustic event below 20 hertz could be easily measured with this low frequency microphone. On contrary, very high level, very high frequency, like in a, for instance, high-speed train today, very common in every country, the high-speed train with a very high level of sound, or the sonic boom or some fighters. In this case, you have the above 20 kilohertz up to, I don't know, maybe 70 kilohertz, and also very high level above under 40, under 50 dB. Just to give an idea that we can cover any type of measurement in the acoustic, not only sound. And in fact, these are very short, impulsive measurement, right? Measuring the short of the arms. In this case, 378, 812, 877 is only the microphone. 378 is including the preamplifier. Can measure up to under 76 dB, which means you can easily measure the shot during shooting of a gun, and you measure the sound produced in order to particularly protect the people from this kind of level. And of course, also for explosion. And for explosion in a closed field, you can see the pencil probe, very famous by PCB, the one that I use in the Kalama Desert, right, Nicholas? And then the microphone when you want to measure the explosion, very far away distance, of course. Okay, I hope I give you some idea. I would like to finish with your Chile typical application, which is the mining, right? Above and under the ground, the typical, the only explosive proof intrinsically safe microphone for this application, okay, is the 378 EU2EX, which means ATEX approved. Thank you very much. It was a long one, almost 1 hour. I tried to be shorter, but I really need your question, please. Thank you.
Thank you very much, Carmine. Can you see? I'm unmuted. Yeah. Okay. Sorry. Thank you very much. It was the great presentation, especially the application recollection, mostrando la versatilidad de aplicaciones para las cuales podemos usar micrófonos. Quería solo agregar, antes de abrir las preguntas, de respecto de cómo podemos medir, cómo podemos tomar los datos de estos micrófonos, cómo trabajamos, o sea, qué tipo de adquisición de datos podemos utilizar. ¿Dónde está? Solo quería agregar.
That's interesting one.
Una de las maneras de adquirir esto, de cómo conecto mi micrófono a mi sistema de adquisición de datos, o sea, perdón, de cómo obtengo datos de este instrumento. Una de las opciones de Model Shop, que fabrica sistemas de calibración, también fabrica algunos equipos, soluciones digitales, como les llaman ellos. DIDAC, uno de ellos, es un equipo alimentado por USB para sensores piezoeléctricos, ISP y EP, con micrófonos o acelerómetros, que, bueno, tiene resolución de 24 bits, pero es plug and play, es reconocido por Windows como un micrófono, es reconocido por Mac o Android o equipos con Linux como un micrófono. Por lo tanto, a través de drivers y de la compatibilidad de software como Python o MATLAB, podemos medir directamente este equipo. Es detectado como un micrófono más. De hecho, yo antes de esta reunión estaba usando el micrófono, esta interfase como una interfase de audio de alta resolución para acondicionar estos micrófonos. Es una manera como súper sencilla de, por ejemplo, mediciones binaurales, o quiero medir vibración junto a acústica, o hacer análisis modal en 2 canales. Es un punto de entrada súper potente para... Aquí lo tenía, ¿no? Para poder utilizar estos equipos. Sí, ahí está conectado el micrófono. La segunda opción, cuando ya queremos trabajar con más canales, lo que podemos ofrecer son sistemas de Divisoft, Sirius y IOLITE-X, que van desde 4 a 16 canales. Tiene una frecuencia un poco más alta para, por ejemplo, llegar a usar estos micrófonos infrasónicos. Una mayor resolución de ADC, y la opción, por ejemplo, de integrar mediciones de video, de GPS, de vibración, al tener una mayor cantidad de canales, y por lo tanto también trabajar con mediciones de holografía, por ejemplo. Y bueno, esto no es directamente compatible tal vez con MATLAB o con Python, como puede ser D-User, también el costo es distinto, pero sí el software ya trae una solución prepaquetizada para distintas aplicaciones acústicas, como sonometría, potencia de sonido, intensometría y calidad acústica. Y una tercera opción que no está aquí es la interfase, es el, ¿cómo se llama esto? El preamplificador Phantom de PCB Piezotronics. Sí, que permite, puede ser adquirido de manera con un kit junto a un micrófono, o ser utilizado con otro tipo de micrófonos de 1/4, media pulgada, para adquirir datos a través de una interfase XLR existente. Son como 3 maneras de poder completar la cadena entre el micrófono y tener el dato para su análisis. Y bueno, quería agregar eso, y ahora dejar abierta la ventana para cualquier comentario, pregunta.